Hey, this is Step Amit. Welcome to my exorcism.io series. In this video, I'll be working through the prime factors exercise from the exorcism.io Ruby track. So our task here is to compute the prime factors of a given natural number. And we're reminded that a prime number is only evenly divisible by itself and 1. So we want to find the prime numbers that that make up our number that we've been given. And it says, note that 1 is not a prime number. So even though we will get to 1s, 1 will not be in our results. So here's an example of how this works. So what are the prime factors of 60? So the first thing we do is we start with 2, which is the first prime number. And we see that 2 goes into 60 evenly, and it leaves 30. So then we have 2. So then we take 30 and we do the same thing. 2 goes into 30 evenly, leaving 15. And okay, so then we have 2 and 2. So then we take 15 and we do the same thing. We start with 2. 2 does not go cleanly into 15. So we increment and go to 3. 3 does go into 15 evenly, leaving 5. So then we see that 3 does not go into 5. So the next possible factor is 4. We increment 3. 4 does not. We increment again. And then we see that 5 does go cleanly into 5. We're left with 1. And so we're done. So our successive divisors from that particular list are 2, 2, 3, and 5. And then if you multiply them back together, you get 60. So this is our task. And the way this is described, this is either an iterative operation, or I think maybe better understood, a recursive operation. So we're going to come up with a recursive algorithm to solve this. Let me grab that. Start a new TMUX session. Get rid of there we go. Let's open up the tests. My test running pane. And then run the test, which will fail because we do not have because of a typo. But it will fail because we do not have our file primefactors.rb. So, okay. Actually, before I get too far into it, let's just look at what we have here. We have a class named primefactors with a class level method of that takes a number and returns an array of the prime factors. I think that's all we have. Yep. All right, so let me go ahead and open up primefactors.rb and reverse my panes, run again. And I need to, it's going to fail because I haven't initialized my class. Next, it's going to complain about the of method. So there we go. Let me go ahead and initialize that. And next it'll complain about this version because of the arity of the of method. I need to make it accept an argument, which it is not right now. So let me go ahead and do that. And I'm going to call it number. Yeah. And then lastly, it'll complain because it's expecting an array back. And I'm not returning an array, returning nil. So I'll simply hard code this response. And everything will be happy now. And actually, I'll wait till I have to. So test 2, so 2 is going to return 2 here. So let me go ahead and run this test. And it'll fail, of course, because we're returning an empty array. So I've got to do something to implement this functionality here. So I think what I'm going to do, because this is where this recursive function is going to be headed anyway, I'm going to explicitly return an empty array if number is equal to 1. Otherwise, I'm gonna set a divisor equal to 2. And because that's where we're going to start for each of them, if you remember. And I'm going to return a new array with the divisor. Let me explain what this is. And this will work. This test will pass. I haven't run it. You got to actually run the test. Got to actually run the test for it to pass. That's really weird. So what this is, this looks weird, right? It's like I've got a class name with open brackets, and then I'm giving it an argument. Like, what in the world is happening here? So what's happening here is this isn't actually the class name array. This is a method name that is a method on kernel in Ruby, and it is this array method is a convenience method that will do its darndest to convert whatever you give it into an array. And so it's simply a shorthand way of, the way you would usually use this is if you've got some kind of input to your method and you're expecting an array, rather than checking the type, which, we don't want to do that. You don't want to be checking types all over the place or checking for nil. Instead, you simply could take your input and do this, is pass it to this, and then you've got an array. And if that breaks, it's a really, you've got a really exceptional circumstance. So anyway, let's keep going, and I'll keep building this out. So the next is going to be 3. And this, of course, will fail because we're returning 2. So what I need to do now is, if I look back at what's happening here, is we're going to check to see if our divisor goes evenly into our number. And if it is, that's our factor, right? That's our factor. But if it doesn't go evenly in, we're going to increment until we find the number that does. So what I want to do here is, after I set it to 2, I'm going to increment divisor. So plus equals 1 while number modulo divisor is not equal to 0. So while number is not evenly divisible by our divisor, we're going to keep incrementing it. And this will be enough to make that next test pass. All right. And then now we're going to have to introduce our recursion on this test, because we're going to have a single 1, but it's going to be, a single 2, but we need two 2s. And so what we simply need to do is, so like, let's think about what's well, here, I'll just show you. What we need to do is we need to take our array that we've created here with our divisor, and we need to add the results of calling of again with number divided by the current value of divisor. And let me just walk through and explain what's happening here. On our first example, let's just say here, when we had 3, this will be an easy one to understand. When we had 3, I passed in 3. We got past this because number was not equal to 1. So we set divisor to 2, and we checked, is 3 modulo 2 0 is the remainder of the division operation of dividing 3 by 2. 0? No, it's not. So, okay, increment divisor. Let's check again. Is 3 evenly divisible by 3? Yes. Okay, cool. So we're gonna go on. And then here we have our array divisor. So we have an initial array here with 3 in it. And then we're going to add, we're going to call of with 3 divided by 3. So that's 1, right? So then we're going to come in here, 3 divided by 3. If the number is 1, it returns an empty array. So we're going to add an empty array to our array, which ends up being 3. So this test passed. What about this one here that we just ran? Okay, well, let's do the same thing. 4. We have 4. Is 4 evenly divisible by 2? Yes. Okay, cool. So array is initially, our initial array here is 2. And then we're going to add the results of calling of with 4 divided by 2. So it's 2, right? So we pass in 2. So is 2 evenly divisible by 2? Yes. All right, cool. So then again, we have array divisor 2 plus of with 2 divided by 2, which is 1, which again, we know that's going to return an empty array. And so we end up with an array of 2, 2. All right, see how that recursion works? So I think that's our whole algorithm. I think the rest of these are just going to pass. Let's see. Yes. All right, 8, we should get 2, 2, 2. Yes. 9 should be 3 and 3. And that's gonna pass. 27, 3, 3, 3. Yep. 625 should get 5 5s. This will just pass. 90, what is this? 901,255. I have no idea how long this is going to take to run, but we should get back 5, 17, 23, and 461, and this should just work. Oh, that's pretty fast. Okay. Oh man, what is this? This is 93,819,012,551. Oh man, let's see how long this takes. Oh, super fast. This is super fast. What a great algorithm. I thought that was going to take forever. Okay, cool. Well, let's look at this. Is there any refactoring here that we should do? Well, you know, we can do something that I've done in a couple of these videos before. What I like to do here is, instead of, you know, I like to give things names, right? Little bits of logic like this. And so this number modulo divisor is not equals to 0. If you know what, you know, modulo is, you can kind of figure out what the intent is. But this is really the how. It's not the what of the intent. Really what I want to know is number divisible by divisor? Is it divisible by divisor? Well, divisible by does not exist on integer. So let me go ahead and implement it real quick. I'm going to open up integer and define divisible by, giving it a divisor. And of course, the guts of this are going to be exactly what we took here. Self modulo divisor is not equal to 0. All right, cool. That looks pretty readable to me. And I'm going to go ahead and submit that. And I'll see you in the next video.